Hello students, welcome back to our channel Abhyas IT Prep. So today we are going to explain about 22nd Jan shift physics paper. So let's get into the video. If you see the first question, see that one. A solid sphere of mass 5 kg and radius 10 centimeters is kept in contact with another solid sphere of mass 10 kg and 20 centimeters. Then moment of inertia of this combination. So we are having two spheres. So just wait. We are having two spheres. So see here, two spheres of radius 10 centimeters, and one more sphere is there with radius 20 centimeters. With 20 centimeters. They have given mass 5 kg, and one more is there 10 kg. Mass is 10 kg. What they are asking? They are asking for the moment of inertia. So we know that one parallel axis theorem. From the parallel axis theorem, we know that one moment of inertia can be written as moment of inertia through the center of the mass, and moment of inertia through the edge. So we know this formula: 2 by 5 mr square plus mr square. From this one you can write like this one: 7 by 5 mr square. This is our moment of inertia of the solid sphere. So for this condition you have to find total moment of inertia. So for total moment of inertia we know that one, for total moment of inertia I total equal to I1 plus I2. So from this one you can write like this one. So 7 by 5 mr square. 7 by 5 mr square. I am writing directly. Please consider. So 5 into mr square, 10 whole square plus 10 into 20 whole square. It is in centimeters. You have to convert that into meters. So if you solve this one, you will get the answer 0.63 kg meter square. So what is the correct answer? Option 4 is the correct. So next question. See that question number 27. 7.9 mega electron volts alpha particle scattering from a target material of having atomic number 79. For this given data, the estimated diameter of the nuclei of a target material. What they are asking? Diameter. If we know the radius, we can easily find out the diameter. So our diameter D can be written as 2r. So we know that one law of conservation of energy. From this one, initial energy is equal to final energy. So what are the initial energies? Initial kinetic energy, initial potential energy must be equal to final kinetic energy plus final potential energy. So what is the kinetic energy initial? So 79 mega electron volts. So what is the kinetic energy? 79 mega electron volts. So what about initial potential energy? 0. This is equal to final kinetic energy 0. So potential energy, we know that one. Alpha particle He plus 2. So see here, what is the charge for alpha particle? 2e. What is the charge for another atom? Charge for another atom, take it as QA, ZE. ZE. We know that potential formula, potential V or U, whatever it may be, equal to K Q1 Q2 by R. Q1 Q2 into K Q1 Q2 by R. So see here, what is the K? K can be written as 9 into 10 to the power 9 into K. So first charge 2E, I will write again E. So what is the Z? Z value 79 plus into E square, 1.6 into 10 to the power of minus 19 whole square. I am writing here. Okay, I hope you are understanding. K 2Z E square by R. Cancel out. So 7.9. So 7.9, 79, 10 times. Again 1.6, 1 time. Okay, 10.6. This is 3. So if we calculate the R value, you will get R value as 2.88 into 10 to the power minus 4 meters. 10 to the power minus 4 meters. This is your R value. If you cancel out these things, you get the answer. So option 3 is the right answer. So next one, see here. Good. What is the question? There are 6 point charges are there around a circle. The charges are having angle between the charges is 60 degrees. But the charges are making angle 60 degrees with each other. 60 degrees, and this is 30. So you have to find the net electric field at the center of the charge, center of the circle. You have to find net electric field at center of the circle. So if you observe these plus Q and plus Q, you won't get any net charge. And plus Q and plus Q, you won't get any net charge. So observe these two charge, minus Q and plus Q, you will get a net charge. By this plus Q, you will get net charge E. By this minus Q, you will get another net charge E. So what is this E? E is nothing but KQ by R square. KQ by R square. So how to find that one? How to find that 2E? We are getting here net 2E charge, 2E electric field. So if you write like this one, this is our x-axis, y-axis. We are having net electric field 2E. Theta is 30 degrees. You have to resolve the forces. If you resolve x-axis, you will get a 2E sine 30. If you resolve in y-axis, you will get a 2E cos 30. So what is the net charge? So simply you can write E net can be written as E cos 30 1 by 2 cos 30 degrees minus I cap plus sine 30 degrees, that is plus j cap plus j cap. If you solve this one, you will get the answer. So see here, this is 1 by 2 and root 3 by 2 here. If we cancel out 1 by 2, 1 by 2, you are remaining with minus 1 root 3. So there is a option mistake is there. So see here, so you will get option 4. What is the answer? I will write here, q by 4 pi epsilon naught r square into root 3 j cap minus I cap. Root 3 j cap minus I cap. Okay. So next question. So next one, see here, question number 29. So observe this. So I am explaining the question here. So PQR is there. So R is the resistance given here, and one rod is there, CD rod is there. It is falling from the rail. So induced EMF. This concept is belongs to motional EMF. So XP Q by is a vertical smooth long loop having a total resistance R, where Px is the parallel to the Qy. So Px is the parallel to Qy. So and separation between them is L, and a constant magnetic field B is perpendicular to the plane of the loop exists in the entire space. A rod CD length capital L and mass M is sliding down from the rest under gravity. So it is moving down under gravity. So under gravity force, magnetic force is nothing but mass into gravity. It is falling under gravity. Then you have to find the terminal speed. Terminal speed. So we know that one motional EMF from motional EMF. We know that one magnetic field force. So magnetic field force can be written as B square L square V by R. So in equilibrium, Fg must be equal to Fb. So if you substitute here mg b square L square V by R, you have to find terminal velocity V. So if you find that V, you will get the answer. So V can be written as mgr by b square L square. B square L square. So option 4 is the right answer. So next question, see here, question number 30, which is from gravitation, which is belongs to escape velocity. What they are asking, please see. The escape velocity from a spherical planet A is 10 km per second. They have given in kilometer per second. Please observe very carefully. So the escape velocity from the another planet B, whose density and radius are 10% of those planet A. What they are asking? They are asking just a relation. What is the escape velocity? So escape velocity of the planet A. What he is asking? Escape velocity of planet A. We know that the escape velocity formula, escape velocity equal to 2gm by r. 2gm by r. But they have given in density. They have given values in density. So from this one, you can write like this one, 2g, m is nothing but rho into volume 4 by 3 pi r cube by r. So escape velocity is directly proportional to rho and r. Escape velocity is directly proportional to under root rho and r. So escape velocity of a B by escape velocity of a rho B by rho A into RB by RA. If you see here 0.1 of rho A as given in a problem, see here, just wait. So see here, rho A into 0.1 RA R. So if you cancel these things, you will get 1 by 10 root 10. So, but what they are asking? They are asking velocity of the escape velocity of the planet B. So VB can be written as into velocity of the planet A. So 10 kilometer per second. I am converting into meters into 1000 by 10 root 10. So if we cancel out, you will get 100 into root 10. So option 3 is the right answer. Option 3 is the right answer. So next one, see here, question number 31, which is belongs to a current, electricity and meter bits. So very easy. Null point. So read that question very carefully. A meter bridge with the two resistance R1 and R2 as shown in figure. The balanced means Wheatstone bridge is balanced. So R1 by another resistance point. So see here at 40 centimeter from the point P. The null point is changed from 40 to 50 when 16 ohm resistance is connected to parallel to R2 resistor. So they have connected one 16 ohm resistor at R2 parallel to R2. So then what will be the value of a resistance R1 and R2? They are asking for R1 and R2. So what is the first condition? The condition is this is 40 and this will be 60. So at first case, I am writing here case 1. At first case, R1 by 40 equal to R2 by 60. R2 by 60. So from this one, you can write R1 by R2 equal to 2 by 3, or R1 can be written as 2R2 by 3. Okay. What is second case? The null point is changed to 50. Second case is 50 centimeters and 50 centimeters. So what is the condition here? R2 is again one more resistance, that is 16 ohm. That is 16 ohm. So see here case 2. What is the case 2? So R1 by 50 equal to parallel. So we know that formula. So R2 into 16 by R2 plus 16 by 50. 50 gets cancelled. 50 gets cancelled. So if you substitute R1 from here, so see here 2R2 by 3. So 16R2 by R2 plus 16. If you cancel out R2, you will get R2 as 8 ohm. R2 as 8 ohm. If you substitute this R2 in R1, in this equation 1, you will get the R1 value. So what will be the R1 value? So R1 value will be 16 by 3 ohm. So which is the correct option? So option 3 is the right answer. So next question, see here. Question number 32. The projectile is thrown upward at an angle 60 degrees with a horizontal. The speed of a projectile is 20 meter per second when its direction of motion is 45 degrees with the horizontal. Then what is the initial speed of a projectile? Initial speed of projectile. So I am drawing here, please see. This is our initial speed u. It is moving at some point. So it is having theta 45 degrees. Having theta 45 degrees and velocity, what is the velocity? 20 meter per second. And the initial angle, that is 60 degrees. Then you have to find the initial velocity. Take it as initial velocity and this is final velocity. In horizontal motion, so the velocities of horizontal components are constant. So V is a constant in horizontal motion. So you can write like this one, Ux equal to Ux, just right. V is constant, so see, you can simply write Ux cos 60 equal to Vx or V final, whatever it may be, V final or okay, Vx equal to cos 45 degrees. So we know this velocity, that is 20, 1 by 2, that is a root 2. So we know that cos 60, what is the cos 60? 1 by 2. If you cancel out, you will get a root 220 meter per second or 20 root 2. Option 4 is the right answer. So next one, see here. What is the condition here? The horizontal component of velocity in projectile motion is constant. That is the basic thing here. So question number 33, statement based question, which is from mechanical properties of fluids. So what is the statement 1? The pressure of a fluid is exerted only on solid surface in contact, as a fluid pressure does not exist everywhere in still fluid. So what they are saying, the pressure is does not existing everywhere in still fluid. As per Pascal's law, the pressure is always constant at every point of the still fluid. As per Pascal's law, at every point of a liquid, inside a liquid, the pressure is constant. So this is the wrong statement. So statement 2, the excess potential energy of the molecule on the surface of a liquid when compared to interior, the results in surface tension. So the interior of liquids are intermolecular forces. So see here the statement 1. What is the statement 1? So what they are saying, they are having excess potential as compared to outermost to interior. So in this condition we are having cohesive forces. So we are having cohesive force. So due to this cohesive force we are getting surface tension. So this is the correct statement. So statement 2 is the right answer. So what will be the answer? A statement 1 is a false, but a statement 2 is a true. That is the right answer. So next one, see here. Find the correct combination of A, B, C, D inputs which can cause LED to glow. So this is from electronic devices, logic gates. So how the LED will glow? If you observe, we are having PN junction diode. For a PN junction diode, you must have, if you want to glow that LED, the PN junction diode must be in forward bias. Must be in forward bias. Forward bias. What is the forward condition? So you must have at positive side, you must have high potential, that is 1. At a negative side, you must have the low potential, that is 0. That is 0. This is our task, to get a 0 here and 1 here. 0 here, 1 here. If you observe, this is A bar, and what you are getting? A bar dot B bar whole bar. That's why you are getting A plus B. So in this output, how do you are getting? C bar dot D bar. So which is the option? 0 1 0 0, 0 0 1 1, 0 1 1, or 1 1 0 1. So if you check this one, you will get the answer 1101. Option 4 is the right answer. So next one, see here, question number 35. The net gravitational force at the center of the square is found to be F1. Is found to be F1 at this position. It is F2 when the position of 3m and 4m are interchanged. 3m and 4m are interchanged, then we are getting force F2. Then what is the ratio to the F1 by F2? So see here. So F can be written as G m1 m2 by r square. So for ratio, we can cancel this r square G. We are taking ratio. That's why we are only focusing on the masses. So if you observe here, they are asking at center. We are having force between capital M and 3m. Capital M and 3m. So it is opposite to each other. It is opposite to each other. So in this case, the force is depending on the m, mass. So the capital 4m and 2m is opposite to each other, that is the diagonal. So the force is acting diagonally. The force is acting diagonally. So see here, if you observe, this is, so see here, F net, we know that one. F net can be written as F1 square plus F2 square plus 2F1 F2 cos theta. So the net force is acting along diagonals, along the diagonals. So what is the angle here? Here you are getting angle 90 degrees. 90 degrees. Then it will be 0. So from F1 plus F2, for masses 3m and m, you will get a net mass is a 3m minus m, then you are getting 2m. So substitute here because f is directly proportional to m now. So similarly 4m comma 2m, m net can be written as, that is 2m also. So for case 1, what is the f net? For case 1, what is the f net? So f net can be written as, I hope you are understanding, f net can be written as, so root 8m, or you can simply root 2m. This is for case 1. What about case 2? If 4m and 3m's are interchanged, take it as a 3m, take this one 3m, here 3m, 4m, m, 2m. So force is acting diagonally. So this is the condition. So case 2, see here, case 2. So m net for 3m and 2m, m net can be written as m. For 4m and m net can be written as 3m. So what is the f net? Second case, or you can say this one f2, take it as f1, f2. So what is that? Root 10 m. If you observe, we have to do that f1 by f2. We have to find the value of alpha. So what is the f1? f1 by f2 can be written as 2 root 2, gets cancelled, and root 10. So root 2 root 5. So root 2 root gets cancelled, 2 by root 5. So this is actually root 5. So what is the value of alpha? Alpha is nothing but 2. Alpha is nothing but 2. So next question, see here, 36. Question number 36. So the minimum frequency of a photon required to break a particle of mass, they have given mass in atomic mass unit into 4 alpha particle is, what they are asking? Frequency. What they are asking? They are asking the frequency. We know that formula, energy. So I am writing here, energy E equal to h nu. So we want frequency. Frequency can be written as E by h. So what is E? E is nothing but mc square. So we are taking a change in mass square by h. Okay. So first we have to find this quantity. I am finding here. So delta m into c square. I will write c square last. So what is the initial mass? This is initial mass. This is final mass. What is final mass? 4 into alpha particle. What is the mass of the alpha particle? Here, helium particle, 4.002. 4.002 AMU. I will convert that AM into kgs from here. So see here, 4.002 minus 15.348 into AMU, that is the AMU by c square into c square. So from this one, What you are getting? This is 16. So you will get a 1.00, sorry, 1.48. You will get a 1.34 AMU, that is nothing but 1.66 into 10 to the power of minus 27 kg into 3 into 10 to the power 8 whole square. 8 whole square. So if you substitute these values delta m square in this equation, you will get the answer 4. After calculation, you will get the answer for 14.94 into 10 to the power 19. So next question, see here. So this is very interesting question. Please see. So they have given one system. So this is from thermodynamics. So the mixing of thermodynamics and rotational motion. So a cylindrical tube of A of length L closed at both ends contains an ideal gas of 1 mole having the molecular weight capital M. The tube is rotated in a horizontal plane with constant angular velocity omega about an axis perpendicular to the AB and passing through the edge at an end A as shown in figure. If PA and PB are the pressures at A and B respectively, then what is the relation between P and A? P and A. So see here, consider one small portion, small part of length dx, of length dx. So we know that when the rotating body, so what will be the force? Force for rotating body m omega square into r. Here we are taking small portion. This is not r, x. You have to take x. That is a perpendicular distance. No need to worry. So see here, df equal to m omega square into x. So if we change that df into pressure, what is the pressure? Pressure is nothing but force by area. So A into dp can be written as m omega square x. If you want to change this mass, you want to cancel that area, so rho into volume, rho into volume. So rho into volume means volume is nothing but area into length. What is area? A. What is the length? We are taking dx into dx omega square x. So this is a dp. A gets cancelled. So dp can be written as rho omega square x dx. X dx. So what you have to find? You have to find the pressure. You have to find the pressure. So if you observe here, we are not having any rotor. We are not having any rotor, but we are having at R and T. So what you have to take? You have to take equation, ideal gas equation, PV equal to nRT, PV equal to nRT. So from this one you can write rho equal to, if you change this n, you can write like this one. So Pm by RT, Pm by RT, Pm by RT. So take this and substitute here and integrate. So see here, integral PA to PB, PA to PB, that is nothing but, so this is a dp, I am writing here and substituting here. See here, Pm by RT into omega square x dx. Omega square x dx. Integral 0 to L. That is the length. So if you write this P left side, if you write this P left side, so by P. So 1 by x, log x. 1 by x is nothing but log x. So if you substitute the values, you will get here log PB by PA, that equal to m omega square by RT, or integral x square by 2. So I am writing here 2RT. 2RT. X square means L. You have to substitute L. That means L square. So what you have to find? PB. So PB can be written as, from this one, exponential PA e to the power m omega square L square by 2RT. M L square by 2RT. What is the correct answer? So option 1 is the right answer. I hope you are understanding. See here, next question. The rods X and Y of equal dimensions but of different materials are joined as shown in figure. X, Y are the rods. The temperature of endpoints A and F are maintained 100 degrees centigrade, and one more is there, 40 degrees centigrade. F is 40 degrees centigrade. Given the thermal conductivity of a rod X, the 3 times of the body Y. So X is 3 times of body Y, that is the thermal conductivity. Then the temperature at a junction point B and E are. What they are asking? How to find the temperature at B and at E. Temperature at B and temperature at E. So take this letter. R can be written as A by R can be written as L by 3Ka. 3Ka. So if you rewrite this figure by substituting R values, see here, X can be written as R, and this is one more, okay, R, okay, X values are R, and this is the 3R and 3R and one more 3R. So if you find this equivalent resistance, you will get R, you will get 11R by 2. This is at point A and a point F. 100 degrees, 40 degrees. So if you want to find heat can be written as change in temperature by resistance, thermal resistance. So for this condition, 100 minus 40 by 11R by 2. This is equation 1. This is the condition. And the next one, see here, B. This is the point B. So next at point B, temperature at point B, at B can be written as, that is 100 minus TB by what is the resistance? R. That is the resistance R. Here, next equation, heat can be written as TE minus 40 by 3R. Equation 1, equation 2 and equation 3. From 1 and 2, you will get the temperature at B equal to 89 degrees. If you solve this equation, you will get. So substitute these, equate these two equations, you will get the answer. So from 2 and 3 equations, you will get the temperature of TE. Temperature at TE, that is nothing but 73 degrees centigrade. Option 1 is the right answer. I hope you are understanding. Question number 40. Consider an equilateral prism of a refractive index √2. A ray of light is incident on one surface at an certain angle I. If the emergent ray is found to graze along the other surface, then angle of refraction at incident surface. Angle of refraction at incident surface. So consider this is one equilateral triangle prism. Equilateral prism. So of having A, triangle angle A, that is 60 degrees because it is equilateral. So we are incidenting one ray. It is refracting here and grazing. It is grazing at another surface. Grazing means it is getting, this is R1, R2. So it is getting total internal reflection. What is the total internal reflection condition? The emergent ray is at 90 degrees. Total internal reflection. So from this one you can write N2 sin R2, that is the N1 sin E emergent. So that is the 1 E. What is the E? So the emergent angle is 90 degree. The emergent angle is 90. That is correct. So sin 90. Sin 90 is nothing but 1. So 1. So what is the refractive index of prism? That is √2. So sin R2 can be written as √2. So R2 can be written as 45 degrees. So we know that formula A equal to R1 plus R2. We have to find R1, that is A minus A. So see here. What do you have to find? You have to find the R1. So A minus R2. A is nothing but 60, R2 is nothing but 40, 45. Then R is nothing but 15 degrees. Not centigrade, 15 degrees only. So then what is the correct answer? So option 1 is the right answer. So next question, see here. Question number 41. The volume of an ideal gas increases 8 times and a temperature 1/4 of the initial temperature during the reversible change. If there is no exchange of heat in this process, so here what they are saying, delta Q is 0. Then identify the gas from the following options. So what they have given? They have given condition in volume and temperature. They are asking what is the gas. How to find this one? So we know that equation PV to the power gamma equal to constant, and also TV to the power 1 minus 1 is also constant. take this condition 1 and condition 2. So TV to the power gamma minus 1, T is 8 times increased, so 8T, and volume, what is that? Volume is increased to 8. Volume is increased to 8 and T is decreased by 1 by 4th time, that is T by 4, it is 8V whole to the power gamma minus 1. So if we cancel out T and V, you are remaining with the 4 equal to 8 to the power gamma minus 1. So 2 to the power 3, 3 gamma minus 3. So from this one you will get a gamma equal to, so see here, from this one you are getting gamma equal to 2 square, 5 by 3. So what is the gamma value for monoatomic gas? So gamma value for monoatomic gas is 5 by 3. That's why the gas is helium gas. Next one, see here, 42, question number 42. What they are asking? So the relation between potential, electric potential and electric field. What they are asking? They have given electric field, and what they are asking, electric potential at point 10 comma 20 is 500. Then what is the electric potential at the origin? What they are asking, electric potential at the origin. So see here, we know that formula, potential V equal to minus integral E bar dot dr, E bar dot dr. So from this one, see here, so substitute the values, integral E, what is A value? 5. What is the A value? 10. 10x I cap plus 5 y j cap into x dx I cap plus dy j cap integral 0 comma 0 to 10 comma 20. So take it out. Ten x square by 2, I am writing 2 here, x square, what to the x, so that is nothing but a 10 square plus what is here 5, y square by 2, what is y here 20, so 20 whole square, 20 whole square. Have to take here change in potential. So change in potential, final minus initial, what is the initial? 500 volts. So if you solve this work, you will get a 1500. So from this one, V naught can be written as 2000 volts, 2000 volts. So I hope you are understanding. So next question, question number 43. A simple pendulum has a bob with a mass m and a charge q. The pendulum string has a negligible mass. When uniform and horizontal electric field E is applied, then the tension in the string changes. The final tension in the string when pendulum attains equilibrium position. Very, very simple. So see here, take this. This is my pendulum. This is bob. Tension is acting upward and downward you are acting gravitational field, and one more is there, electric field, that is Q into E, Q into E. So what is the tension in equilibrium? At equilibrium, tension must be equal to mg square plus q square. So this is the equilibrium condition. Very, very simple. So option 3 is the right answer. So next one, see here, match the list 1, list 2. They have given some constant values: spring constant, thermal conductivity, Boltzmann constant, inductive reactance. They are asking dimensional formula. So for spring constant, no need to solve, you have to remember. So spring constant F equal to Kx. F equal to Kx. We know that one. From this one, I want to find K. So what is K? What is F? ml t to the power minus 2 K into x. That is the length. You can cancel out. So K, dimensional formula for K is nothing but ml naught to the power minus 2. This is for spring constant. What is about thermal conductivity? Thermal conductivity. Thermal conductivity. dq by dt equal to Ka into delta T, that is change in temperature by length. So see here, what is dq by dt? Rate of change of charge m l square to the power minus 3. So here I am writing small k. A is nothing but L square, and the temperature is nothing but capital K, and the length is nothing but L. So if you cancel L, you will get the answer. So thermal conductivity K can be written as M L to the power minus 1 T to the power minus 3 into K inverse, that is temperature. This is thermal conductivity. So spring constant m L naught, this is 2, and thermal conductivity T to the power minus 1, this is thermal conductivity. Okay. So next one, see here, Boltzmann constant 1 and inductive reactance 3. So therefore option 4 is the right answer. So next one, see here, 45. Question number 45. 3 identical coils C1, C3 and are closely placed such that way a common axis C2 is having common axis. CT is exactly at midway. C1 carries a current in anti-clockwise direction while C3 carries a current in clockwise direction. An induced current flow through the C2 will be in clockwise direction when. So we know that formula, Lenz law. According to Lenz law, so see here, I am taking coil 1, coil 2 and coil 3. So coil 1 is having anti-clockwise direction, current in anti-clockwise direction. Take it as C1, C2, C3, and C3 is having a clockwise current. According to Lenz law, when we are taking away this C1, it will produce same current, that is anti-clockwise current. Same current, attraction, same current. If C3 is going towards the if C1 is going towards the C2, what will happen? It will induce opposite current. It will induce, this is anti-clockwise, you will get the clockwise current. You will get the clockwise current. This is the condition. You will get the clockwise current. So what they are asking, if C2 will be clockwise, so I need to get clockwise direction. So C1 must be towards the C2. C1 must be towards the C2. What is this C3? C3 must be away from the, so C3 moves away from the C2. So that is the option 2 is the right answer. So next question, see here, 46, question number 46. What they are asking? So two loudspeakers L1 and L2 placed at with a separation of 10 meters as shown in figure. Both speakers are fed with an audio input signal of a same frequency with constant volume. A voice recorded initially at a point A. The initially at a point A. The both speakers are at equidistance is moved by 25 meter along AB line. So this is a 25 meter. So 25 meter. They have moved this one along the AB line. While monitoring the audio signal, the measured signal was found undergoes 10 cycles of a maxima and a minimum. They have given the n value here. This is n. During the movement, the frequency of the input signal. What is the frequency? Frequency of the input signal. In this question, we have to find the frequency. So frequency can be written as V by lambda. We have to find lambda. We know that one delta x, the path difference can be written as n lambda. If you find this delta x, you will get the lambda. If you substitute lambda here, you will get the frequency. You will get the frequency here. So next one, see here. So how to find the delta x? Delta x can be written as, so see here, from this one, from L1 to B and L2 to B. So BL2 minus BL1. This is right angle triangle. So from this one you will get what you are getting, BL2. So this is 5 centimeters actually initially, and it is moved to 25 centimeters. That is 25. So from this one, 30 whole square plus 40 minus right angle triangle. I am finding hypotenuse, minus 25 minus 25 whole square plus 40. If you solve this one, you will get answer 5.4 meters. So from this delta x formula, n equal to 10, that is lambda. So lambda can be written as 0.54 meters. So they have given in velocity. So from this one you will get 324. Velocity is nothing but 324 meter per second, and the lambda is nothing but 0.54 meters. So if you solve this one, you will get 600 H. This is your answer. So next question, see here, 47. The electric field of a plane electromagnetic wave traveling in a unknown magnetic medium is given by electric field they have given. So the dielectric constant in the medium is, they are asking dielectric constant. So we know that one velocity can be written as omega by k. Velocity can be written as omega by k. So and refractive index n equal to c by v. So for non-magnetic medium, you can write like this one, c equal n equal to refractive n equal to under root mu r epsilon r. For non-magnetic medium, epsilon r is 1. So this is equal to under root epsilon r. So if you find this n, you will get the epsilon r. So what is omega? So omega is nothing but 4.5 into 10 to the power 14 by what is k? K is nothing but 3 into 10 to the power 6. So from this one you will get 3 into 10 to the power 8 by 2. So this is V. From this n formula you will get n equal to 2. So if you substitute in that equation, what is the dielectric constant value? Dielectric constant value is 4. So next one, see here, question number 48. A parallel beam of light traveling in air of refractive index of 1 incident on a convex spherical glass of surface radius of 50 centimeters. The refractive index of the glass is 1.5 meters. So the rays covers the point at a distance x centimeter from the center of the curvature, the spherical surface, the value of the x. What they are asking? Parallel rays, very simple. So parallel rays, this is our glass, we are getting parallel rays. The reflection at spherical surface U2. So U2 by V minus U1 by U equal to U2 minus U1 by R. What is the U value? U value is infinity. So this will be 0. So what is the U2? What is the U2? 1.5. This is our U2. So 1.5 by V you are getting. So 1.5 minus 1 by R. What is that R? R is nothing but 50 centimeters. R is 50 centimeters. R is 50 centimeters. So from this one you will get, this is 1.5, that is 3 by 2 V, 0.5, that is 100, 50. So V can be written as 150. V can be written as 150. What they are asking? They are asking at a distance, they are converging at a point x, at a point some x, that is nothing but focal length. So it is measuring from the center of the lens. So x can be written as V minus R. So what is V? 150 minus R, that is 50, you will get 100. 100 is the right answer. Next one, see here, question number 49. What is the question? A circular disc has a radius R1, thickness T1. Another circular disc is made up of same material, has the radius R2, thickness 2. If the moment of inertia of a disc both are same, then R1 by R2 is, they have given, and T1 by T2 is alpha, then the value of alpha. So first of all, what is the moment of inertia for the circular disc? That is mr square by 2 for body 1, for body 2. Body 1 and body 2. What do you have to take? So remove this. Mass equal to rho into volume. Volume, or you can say this one, rho into pi r t. So substitute this one. Rho gets cancelled, and pi r1 t1 by 2. This is 2. Rho pi r2 t2 This is r1 square r2 square by 2. 2 gets cancelled and rho pi gets cancelled. So see here, this is r square actually, pi r square t. So T1 by T2 is equal to R2 by R1 whole to the power 4. That is nothing but 1 by 2 whole to the power 4, that is 1 by 16. So what is the alpha value? Alpha value is nothing but 16. Alpha value is 60. So next one, see here, the inductance of a coil with 10 to the power 4 turns is a 10 microhenry, and it's connected to the source of 10 volts with the internal resistance 10 ohm. The energy density in the inductor when the current reaches 1 by 3 times of its maximum value is alpha pi into 1 by E square, then the value of the alpha. So what they have given? They have given an inductor which is connected to 10 volts battery of having internal resistance 10 ohm. Then you have to find the energy density. What is the formula for energy density? Energy density is nothing but B square by 2 mu naught. So what is the value of B? B is nothing but mu naught Ni. What is the I value? So I can be written as a voltage 10 by 10. That is the maximum one, that is nothing but 1 by E. If you substitute here, you will get a mu naught square N square I by 2 mu naught. Mu naught get cancelled. What is the value? 4 pi into 10 to the power minus 7. What is the N square value? N square value is nothing but 10 to the power 8. What is the current here? 1 by E. Then 2. If you cancel out this and 1, you will get 1 here and 2. So you are getting 20 pi by E square, I square. 20 pi by I square. So what is the value of alpha? So alpha value is nothing but 20. So thanks for watching our videos. Please do like and subscribe. If you are having any doubts, please comment below. Thank you.